This is going to be a video on integration, but it's just going to be a refresher. So it's not going to go into anything in detail. There won't be any examples. It's just something to jog your memory before an exam. So I'm going to go through some notation when something can be called an antiderivative and the qualities of an integral. So, notation. All an integral does is evaluate the area between 2 points, and those points can be definite or indefinite. Either way, this is how you need to write the integral. If it is indefinite, you don't need to put any limits above the extended s. So remember, when integrating an indefinite integral, your final answer must have an added constant at the end. So once you've evaluated an integral, this is how you'd represent it, so you can further evaluate it. So we can only call something a function, we can only call something an antiderivative if it fulfills the following three properties. So the function is continuous on the specified interval, the function is differentiable on the interval, and the antiderivative holds for the entire function for the specified interval. So if you have a look back at this definition here, it's a lot more formal, and it says let f be a continuous function on an interval ab. A function fx is called an antiderivative for fx on ab if and only if fx is continuous on ab, differentiable on ab, and the derivative is equal to fx. The derivative of the antiderivative will give you back fx. And yes, here it is here, simplified. So basic qualities of integrals. If you switch the limits, you can still evaluate it, just remember to put a negative at the end. If you evaluate an interval, well, a tiny interval, just from 1 to 1, it'll just give you 0 because there's no area you can add two integrals separately, or you can combine the functions as long as they have the same limits. And you can also take out a constant when you're evaluating an integral, which is a very helpful characteristic of integrals. As well as you can actually split up an interval for an integral. If it goes over 0, this can be quite handy for even functions, as you will see in some of your questions. So in summary, an integral finds the area under a graph. We can evaluate indefinite and definite integrals. An antiderivative must fulfill the three qualities, and we also had a look at some basic qualities of integrals. So the next video is going to look at integration by substitution in detail.